Hello everyone, my name is Umesh. Today I would like to discuss concurrency in Rust. So let's get started. So concurrency in Rust you can achieve in two ways. One is using threads, one is using asynchronous functions. Today we're going to learn about asynchronous functions. Probably we will learn about threads in another video. So let's write a simple function. Let's say function say underscore hello. Probably this will um, print. Come on, I always get confused with these things. Okay. Come on, print it. Hello. So call that function, say hello, run cargo watch -x. Okay, so it has hello, it says hello and hello world. To make any function as asynchronous functions, we have to write async keyword in front of that function. So that's it. So we can make any function to async function, writing asynchronous keyword inside the in front of function. So once you write in front function and if you run this code, I don't say hello anymore. The reason being is that every async function returns a future. So if you're familiar with JavaScript, every asynchronous function in JavaScript returns a promise. If the function returns anything or not, but it does returns a promise, right? So if you hover on it, it says the warning, unused implementation of future. Future does nothing unless you say .await or a whole number. So when I write .await as compiler says .await now. So you cannot only use .await only used inside async functions and blocks. So we cannot use .await unless we have async function, right? So and also we cannot make main function to async function. We can do that with other libraries, but we are not going to do that today. To achieve that, we need a couple of libraries. One is futures, one is async yesterday. So I have already installed these dependency into the project for to save some time. So what I'm going to do now, write futures. I think task block, not task. I guess. Let's use then async yesterday. Task block on and write the same function inside block on and say hello. Now let's see. Now block on is spawns a task and blocks the current thread on its result. So the block on will take asynchronous function and it will wait until this function gets executed. Now once if I see this result, I can see main and hello world. So blocks takes a future and returns a t. It's a generic function. Since our function doesn't return anything, so we're not reading anything on it. So generally what I do, it's not a very common practice, but it's my personal taste of it, personal taste to write this thing. So what I'm going to do generally, async function, I'm going to write an async function. I write main, probably executor, write, I'm going to move this, say hello. Write main executor. I want to say hello on await on it. Now it makes sense. So we'll write all our async functions and await everything in here, not here. So we will write a couple of examples and we'll see how do we write concurrent programming in Rust. To do that, we will see how much time it is taking to execute, so that we'll see, we'll check whether it's running concurrently or not. So I'm going to take let now time import time from the std time dot instant dot now. Probably I'm going to remove this one executed now dot last. Now if you see this executed in 500 microseconds. So let's say So I made a notes. So we have seen how to convert a normal function to async function, and we'll write some fake connectors with the DB and Redis. So let's do that. So let's say we have function which connects to database. Now let's say connect DB. Uh, Generally, it returns the client of that database. Let's say our client is string for now, and the connection takes, let's say, takes about 1 second. Thread dot sleep time dot time dot duration from seconds. Now I'm going to wait 1 second. So I'm assuming that database connection takes 1 second. From there, I'm going to return a string from db. So I'm going to call this function right here. I'm going to say connect db await. Let's see how much time it will take to run. So it's going to take about 1 second because we have the connect db function which takes 1 second to connect and returns the client. So let's create one more function which says connect Redis probably, and it returns string. In reality, it doesn't return string, but it returns respective client. It also take 1 second and say return Redis. I'm gonna write on it, copy it, paste it right here. So our code should take about 2 seconds because this is 1 second, this is 1 second, right? We're not printing anything because we're not reading anything from these functions. Let's see db and let phrase. I'm gonna print those two. db. Now let's see. So we have two things. Says hello and says db client, Redis client. So we have two clients. It takes 2 seconds, about 2 seconds. That's fine. But if you see this code right, so Redis does not depend on the DB. That means we can connect, we can run these two functions concurrently. How do you do that? So we will take advantage of a dependency, a package, or a crate features, which helps us to run multiple features concurrently. So I'm gonna import it, features, I think future, and join them. Not join. So we have join, which is a function which takes features as an argument and returns tuple of those features. Okay. So what I'm going to do now? So instead of doing this way, I'm going to write join. Excuse me. Yeah, I'm back. So what join takes is join does is that it takes multiple features and wait till all the features are done. So the first feature is connect DB, and the second one is connect Redis. So both will return the future. So join itself returns the future. So we have to await on it. So if you see, it returns tuple of futures. So if you see the example, we have to await on it. Let's await on it. So let's see, we'll run without awaiting it. So this is not going to run. We should see only one hello, and it executes in 500 microseconds because we are not await on it. So if you're not awaiting on it, what process is going to do is it's not even run that program. So I'm going to await on it. Now let's see how it runs. So it should take about 2 seconds. So it takes 2 seconds, right? So how do we read those values from the join? It's pretty simple. Join returns a tuple. So I'm going to write tuple return db comma Redis, and write this one. So I'm reading those results from the tuple. It should see hello db client db Redis, right? So we have seen how do we make functions concurrently. But if you observe, since we are running these two functions concurrently, it should take about only 1 second, but it is taking about 2 seconds. I might sound a little bit excited because I am. So when I started learning concurrent programming language in the Rust with Async await, I started with this thread.sleep. Then once I saw the results, I was really shocked. Then I later tried to understand is that the async function is not going to create a thread. So both the async functions are going to run in the same thread. Since we are blocking the same thread which the two async functions is running in, we are blocking the whole thread. So there is an interesting article. There is an interesting thread on the Reddit. So it says understanding thread.sleep, blocking inside async function. See, please go through it. Um, you can understand more about that. So I'm going to share that link in the description below. So what we can do, we need a sleeper or asynchronous sleeper, right? So for that we have a sleep function inside std. It's part of task. Let's do that. I'm gonna replace block on and the sleep. Do let's see. I'm gonna replace thread.sleep with sleep from the async std. But if you see that, right, the sleep for the specific amount of time, the function might sleep slightly longer than specified time, but nevertheless, since sleep returns a future, so we have to wait on it. So I'm going to do exactly that. I'm going to wait on it. Let's see. So it should take about 1 second. Now you can see it takes only 1 second, right? So earlier it used to 2 seconds because since both the asynchronous functions runs on the same thread and we are blocking the thread for each second in each function, then it takes about 2 seconds, right? So that's interesting stuff to learn. So we have 2 seconds. So each function takes 1 second. Since we are running those two functions concurrently, it's going to take only 1 second to run. What's the thing we have? We have seen DB connector, Redis. We made them parallel with the vector, mutex, and result. So before we're going to discuss about the vector mutex, so let's write with the result. And I'm going to show you like what if that function returns a result, not just a string or anything else. So what I'm going to do, I'm going to write a function. I'm going to write async function, right? Let's say result. Let's say this returns result of type string. I'm going to write this one. Not care. I don't care about that right now. Write string from hello from the result. Okay, from there I will write like write println right. I can do inside with result dot await dot online. So let's run, see what it returns. Hello DB client, hello from result, right? So what await does, it's wait until that feature executes and returns gives you the same return value whatever returns. So it might return error, it might return okay, doesn't matter, right? So that's with the result, and let's do with the vector. So what happens we have some input words and we want to iterate through them, and we will wait for all the iterators to finish, right? So what I'm going to say, what I'm trying to say is that, so let's say we have first let's write the normal function like read underscore data, um, read underscore data, which takes input a string, returns, it doesn't take string, let's say it takes str and returns a string. I'm gonna write format and say like hello Right input. Um, So let's write thread for the time being. Duration, I think from second. Okay, so we have duration 1 second. Let's say we'll create words of vector, like let words, or let's languages. How many languages do I have? I know languages equal to what's more? Yeah. So I know a couple of languages. My mother tongue is Marathi. I studied in Telugu. I speak English, right? Not very clearly though. So we have the languages I know. What I want to do now, I want to iterate through the read data, uh, then which returns a string, and then I'm going to put that into a new string. Okay, so let's say languages underscore result. I'm gonna languages dot. You don't have to clone. So languages dot I iterator. So let's get the iterator, which will gives me the map with a closure. So I'm gonna write it gives you the language, um, which we will send to read data. Then I'll write the language. That's about it, I guess. Like I can collect it since the collect is generic. I can write which returns a vector of string takes two. It's not languages, come on, it's language. Okay, so I'm not using the language results. Let's print that as well. Let's print line, let's say languages result. Oops. Languages result. I'm gonna write this one, that one. Let's see. Let's wait for language result. So it should take about, we have 3 and this was 1. It should take about 1 second. Yep. That means like these 3 taking each 1 second, then uh, these 1 second functions runs concurrently, so we have a total number of 4 seconds. So we have this thing, but what if we want to run these languages concurrently, right? So what's the first step? The first step is to make this function as asynchronous function. And since each reiterator value from the read data doesn't is not so each instance iterator of that data is not dependent on its previous result, right? So we can make this function run concurrently. So what is the first step? I'm going to make read data as a async function. Come on, async function. I'm not going to use thread. That was just since I cannot do await on this sleep from the async yesterday, just I was using thread. So await on it. I'm still going to return string. If you see, right, uh, now if I run this code, I should get an error, right? So that will be of type collect, because since it doesn't return the vector type, it returns iterator future, right? So I don't have to bother about it right now. So I'm going to remove it, the collect. So if I remove the collect, it says I get the map into iterator of future, right? So since the read data returns the future, I get those data from the future. So what I can do, I have now a vector collected iterators, right? So I have like not iterators, futures. So what I'm going to do now, there is something called join all. So what join all does, so join takes standard number of futures, like 1 or 2 or 3 or 4. What journal is going to do, it's going to take a vector of futures. Since I know that this map returns the vector, I can add join all. Where am I? Join all onto it, and right here. Since join all returns promise, sorry, future, so I have to wait on it. So now it knows that it wants to return the vector. Now you can see instead of taking 4 seconds, it is taking 2 seconds. So if you see that, right, so when you have a wait, your compiler or like your language, before compiling, it doesn't know the value of it, but you can actually specify what type of value you're expecting. So I'm expecting vector of string, so that should be fine. That should say take about 2 seconds. Since I'm not using thread anymore, I'm not going to write. I'm going to remove it basically. Do we have anything to improve upon? No, I guess. So let's say what if what if I give a wrong type? Let's say I'm going to say I'm expecting vector 32, but actually the read data returns a string, and I'm putting this into iterator, and this returns a future which have the string as output. So let's see what happens. That's a pretty interesting one, right? So at the compilation level, your Rust knows that this is going to return vector string, not vector I32. So expected I32, but the found struct string. So this is returns a string, but expected is that. So still we have type safety even if you use async functions. So I think that was good. Okay. So let's discuss. We have discussed about vector. We discussed about result. Let's discuss about mutex. Now let's say it's a pretty interesting one, right? Okay. Okay. So let's say let's write function, normal function, not async function. Let's say get cities, and probably it returns a vector of type string. To make compiler satisfying. Okay, so what we're going to do here, I'm going to write down the number of cities that I've been, and let's see how it goes, right? Mm, okay, so let's say let cities I have been. I've been to multiple cities in India. String. Okay, so there is a reason why I'm using string, not the str. If you are going to write str in a vector and pass that to a function, then it creates a problem of lifetimes. If you're not aware of lifetimes, probably I'll make a video on lifetimes. But there is a great video from the John, released a couple of days back. I'll be sharing that down in link in the description. So remember that you can do str as well, but to understand and to shade those str from one function to another function of the vector, it needs lifetimes, but I don't want to discuss lifetimes in this video, so we will use vector of string, not the str. So I'm gonna write a vector. So I'm from Hyderabad, but I've been to where I've been to. I've been to Chennai. Actually, I stayed 1 year in Chennai. I've been to Delhi. I think that's about it. It should be fine. So I have number of cities. Then let's say if I go to each city, so I have city names and I want to say like visited Hyderabad, visited Chennai, something like that, right? Okay, so to do that, I'm gonna write function, say welcome to city, not welcome, let's say namaste. So what I'm gonna do now, like I'm gonna send the vector of cities. So cities, I'll get the mutex of string so that I can make trade of it. Um, Not mutex, no. Why won't you? Like, I'm gonna send the city, man. City and string, and it returns a string. And say like format namaste. What do you say namaste? City say namaste. I'm gonna add this namaste to my add namaste to user directory. Okay, so oh okay. So say namaste. I'm gonna iterate through that function and get the value. Um, let's say each namaste. So let's say each namaste takes some time. Thread dot. I'm gonna import it. Sleep time duration from 1 second. Let's say each takes 1 second, and then returns a string. Then let namaste underscore cities. What I'm gonna do, I'm gonna iterate through them like cities dot into iter. I'm gonna map over it, which returns a closure, which returns a city. Say namaste, say namaste, which takes what? Is that what I wanted? It's the same example that I have written. Oh, idiot. Oh my god, I'm an idiot. Okay. Not bad. It's still great. Um, so I'm not going to use the iterator. So let's say I'm going to write let namaste result is type of vector. Vector is of type string. And let's say let's make it mutable. I'll write for city in cities. Say namaste. Say namaste. It takes city and also cities. I'll say like take city and cities. That is it is like cities of mutual vector of type string. So it doesn't return anything, rather it mutates the array, mutates the vector. Cities dot push the like format. Okay, I'm gonna mutate this cities dot push mutating city. I think it's fine. So namaste takes cities, which is we are sending city and cities. In our case, like namaste result, like namaste underscore cities underscore result. I'm gonna push this and city. This has to be I think that's about it. We don't have any compilation errors. We didn't call this function yet. we'll call this function like get cities, and that's about it. So since it's running taking 1 second, it should take about 5 seconds. Yeah. So let's see where it's taking some time. So we are running these two concurrently. So this will take 1 second, and we have with the result. We have seen the result. Since even though read data takes 1 second for each iterator, since we are running them all the feature at once concurrently, still it's going to take 1 second. So 1 second here, 1 second here, and get cities we have 3 seconds, three things, and we have each sam like thing. So that's about take 5 seconds, right? That makes sense, right? Now I want to return namaste city result, and so uh, I'm gonna like let cities, then print them out cities. I guess so. So we have hello, hello, hello. Hmm. So it's about take 5 seconds, right? So Namaste Hyderabad, Namaste Chennai, Namaste Delhi, right? So what I'm going to do now, since the result of for this iterator is not dependent on this iterator, right? So that means we can run them concurrently. So if you have anything like an old code base which iterates the data and gets the data from somewhere, we can make them run concurrently, and let's see how it goes. So we need to convert this function to async function, and since we have async, so we don't use that sleep thread.sleep, and since sleep returns dot await, um, and hmm, okay, is it that's about it, I guess. Okay, let's run this and see how it goes. Okay, we have error. What's the error? Expected sim opaque type. Okay, since this function returns, so I'm gonna remove this type, since this function now returns future, and it's not the same with vector, right? So I'm gonna remove that. Let's compile and handle it. That's the first error, and the second error is help try adding sim column. Where? Namaste. Okay, try adding sim column here as well. Okay, since we are not awaiting on it, since this code will not run, so let's make await. Now what's there? So only allowed inside function in blocks. Get cities is not async function, so let's make this as async function. So let's see what's the error we have now. We have cities future, so we cannot do that, right? So since cities returns a future, I'm going to do await on it. So it's still taking 5 seconds, right? Because um, we are not running them concurrently. We are still running sequentially, right? So how to make this concurrently? So we have made these two functions concurrently, but we are still running this synchronously, right? So to do that, let's rewrite this also. So I'm going to write vector to satisfy the compiler. What we have done earlier, we're going to do the same thing. So we have the iterator to into it, then joined all, then we have written the result, right? So let's do the same thing. Let's write result Then what we have to iterate through them, like iterator that map, which gives the closure of city. Then mm, then just call the function, say namaste, and we have to, since return cities is a function, right? We can return the cities, so we'll, and city, um, and we have to do the join all. Let's do the join all, add here, add a await here. Is that about it? So cities consider borrowing mutable vector. Since yeah, so since we are sending, so let's mutate the vector. Okay, cannot infer our lifetime expression borrow. So we have mutable vector cities. So cannot infer our appropriate lifetime for a borrow expression due to conflicting requirement. The first lifetime cannot outlive cities. So let's just clone it. Let cloned city. We should not mutate the same thing, right? So let's say namaste city, and what I'm going to do, like it should be of type vector string, this one. So we're iterating on city, and I'm gonna send, it should be mutable, and send namaste underscore cities. So I'm gonna send this right here. So we are iterating through each city, then we're sending city to mutate here, and so this should be a vector. Let's see if we have any errors. Yes, we still have some errors. Expression conflict the requirement. So what we have errors, still we have some errors, right? Parameter in scope. Now, so now the error is, since we have vector which is heap allocated data, and we are sending to async function, and we, since we are sending async function, this function runs concurrently. That means when you have anything which heap allocated and you're trying to mutate it concurrently, it might be a memory issue, right? It might create memory issue. So Rust prevents us from there. So what we're going to do, we're going to use something called mutex. So what is mutex? So if you go to mutex, is exclusion primitive useful for protecting shared data. So mutex helps us to protect the data which we are sharing across the threads. So that's what I'm going to do. I'm going to remove this, remove this, and not just the vector. I'm going to have first the mutex. Where is the mutex? Import the mutex from yesterday. Mutex, that's new, and which will hold the data, right? So generally what I do whenever we have mutex, right? So generally I like specifying the type. So type which will be a string. So type it. So we don't have to, when you have mutex, you don't have to send. So this will be changed from here to here, and from here there is space. So how do we change? We acquire the lock. Mutex will acquire the lock, and what lock does is that that concurrent function, that specific concurrent function, will lock the resource, and it will lock the resource until it finishes mutating the data. So instead of just pushing, so what I'm going to do, lock. So dot lock can result into an error because if that if any thread or any asynchronous function which holds that mutex, and if that panics, this other mutex which other mutexes which held by async function should not able to access the this thing, right? So this will return an error. I'm not care about the error right now. Since I don't need to have mutex, I'm gonna remove that exactly, and let's see what's error. Because necessities string necessities variable function closure. Huh. So we cannot use that, right? So I cannot send the address like a. So we have seen that I have sent the pointer to that function to mutate the data, right? So, but when you're writing concurrent code, we cannot do that. So to achieve that, we need something called arc. So let's see what is the arc first. Write arc, I guess. Sync arc. That's about it. So a thread safe reference counting pointer. Arc stands for automatically reference counted. So if you want to share any data between threads or asynchronous functions, we can use arc. So what arc does, like two syntaxes below the equivalent, we have example right? Yes. So we have arc, which is cloned for each iteration and then passed on to the thread. So we're gonna do the same thing. So I'm gonna take the arc of type mutex of type I'm gonna improve it and take arc new. So what I'm gonna do, so I'm gonna give the clone version for the each thread. So mutex arc, come on, clone. Still throwing the error. Yeah, because it doesn't match the type. Let's see how much time it will take. Now we have it runs in 3 seconds instead of what like we had it was running 5 seconds before. So it still takes like 3 seconds, which is valid. It was taking 5 seconds because of these two functions takes each second, but we are running concurrently 1 second there. This takes each 1 second for each iteration, but we are running those things concurrently, which takes 1 second, and the cities should take 1 second as well. We are returning empty vector, so let's return the result. So if you see that result is of type is not type vector, so we don't know what is the type it returns. Since we don't have to return result, so I'm gonna push that, because since we are mutating the necessities, I'm gonna return that. So which doesn't match with those things. So what I'm gonna do, like lock it, then unwrap it, then clone it. So which gives you the vector. Let's see, I should be able to see. Yes, now you can see we have db client db, right? Then hello from result, we have languages result, hello Marathi, hello Telugu, hello English, then the cities Namaste Hyderabad, and it still takes 3 seconds, right? So had it been like if we have not written the code in a asynchronous manner concurrently, that the whole thing could have taken around 3 plus 3 is 6, then 2 8, about 8 seconds, right? Since we are running um, code concurrently wherever it makes sense, this is going to take a lot less time. So I'm going to take a minute and try to explain what we have done here. If you're sharing any data between the threads, they have to be locked, because all the threads or all the asynchronous function or concurrent functions trying to access the same resource, it might create the deadlock or it might create the unexpected result. So to avoid that, we use mutex. Now mutex is mutual exclusive primitive useful protecting data, shared data. So if you are sharing any data between the threads or the concurrent functions, we have to use mutex, which will protect the data. Now what arc does, so if you're not, since Rust cares about having ownership, um, ownership to each function, so we will use arc. That means we will clone the data and we'll share across the threads. Now what arc means, a thread safe reference counting pointer. So if you have, since we have three, it is going to take, it is going to create a reference to that vector 3 times. So it will increment the counter every time you clone it and pass to that function. So once this function are done working with this arc, now Rust will decrease that counter. So that means like it will be 3 first. Once this number function runs 3 times, it will be 3, 2, 1, and then becomes 0. Then it will drop the arc. Right? So mutex is for protecting the data, and arc is to share the reference of that shared data across the threads. I think that's about it. I think I have covered things that I wanted to cover. We have seen function making normal function into async function, and we have seen how to run two independent functions concurrently, and we have made those functions parallel to run concurrently. Probably not parallel, like probably concurrent. Concurrent. Let's concurrently, I guess. Then we have seen how to wait for all the vectors to finish from the given vector, and we have seen how do we share the data between the threads safely. Um, okay, that's about it. I hope you like this video, and if you have any doubts, please let me know in the comment section below. And since it's been my first video about Rust in YouTube, uh, I wish to improve myself in the coming videos. If you have any suggestions, please let me know in the comment section below. Anything positive or negative, any feedback is welcome. And if you are familiar with Go, I'm planning to make a video on concurrency in Go in the tomorrow, probably tomorrow or day after. I hope you like this video. Thanks for watching, and I'll see you in the next video.